Hello and welcome to another interesting session of math activity. Children, we derived the formula for volume of cylinder in the last activity, which was volume of cylinder is pi r square h, where in a cylinder whose radius is r and height is h, we derived that the formula for volume of cylinder was pi r square h. Today we are going to work on sphere. This is a sphere for you I brought, and we are going to derive the formula for the volume of sphere in relation to the volume of cylinder. Here is an interesting activity wherein we would require a cylinder that we used earlier as well. You remember, this is the circumference of the cylinder, this is the diameter, and this is the height of the cylinder. So you remember we used this cylinder, and I am placing it here, the cylinder, which we used earlier. We are going to use it again. This is a sphere that I brought for you. Important condition here is that this sphere has the dimensions exactly equal to this cylinder. Let's see how. I have placed the cylinder and the sphere adjacent to each other, and this is a scale that I am using. Just see, they have got the same height. They have got the same height, right? What I mean to say is that this cylinder and this sphere have got the same height. They also have got the same radius. How do I show it to you? These are two hemispheres, and just see what happens when I place this hemisphere on this cylinder. Let's see. See, it exactly fits. You see this way. Sorry, now you can see it exactly fits. They have got the same radii. Okay, once again I am placing the sphere for your reference. They also have got same radius, right? Now with this bit of information, I have brought some colored water for all of you. We are going to perform an activity with this. Now, because we are going to compare the volume of cylinder with the volume of sphere, and in turn we are going to derive the formula for volume of sphere, I am going to use this sphere for the practical. Now, this is divided into two hemispheres. See, what am I going to do? I am using this cylindrical trough. I am placing it here. This I am keeping by the side. Let's use this portion. Right? This is colored water, as I told you. I am filling this up to the brim, as we did for the cylindrical volume experiment. You have to be careful while filling it up to the brim. It's done. Next is to transfer this liquid into this cylinder. How much has been transferred? Half the sphere's volume has been transferred into this cylinder. Once again, to make the sphere complete, right? Second time when I transfer, what has happened is that I have actually shifted one full sphere's volume of water into this cylindrical trough. Now this is important. Now what I am going to show you. This sphere full of water has been shifted into this. If I show you this side of the cylinder, this was a graduated cylinder, right? And when I have shifted the volume into this cylinder, what has happened? Are you observing? This is divided into three equal portions. 1/3, this is 1/3, 2/3 and full. You see that the cylinder has been filled only up to 2/3 of its volume. Once again I repeat, what have you observed after this? When we shifted one full sphere's volume of water into this cylinder, which has got same radius and same height, we observe that volume of this cylinder was only 2/3 the inference, what can we draw the inference as out of this? We just saw practically that volume of sphere was nothing but 2/3 of the volume of cylinder. This is the volume of cylinder that we derived. Now let's see. Same, these figures I have drawn over here. These figures are indicating that the radius of the cylinder and the sphere are the same, which we saw practically. Also, we know that the height of the radius and height of the cylinder are also the same. So if height of the cylinder and height of the radius are same, that means h is nothing but twice the radius of sphere. So can I write like this? 2/3 pi r square. In place of h, can I write 2r? Yes? If yes, then it becomes 2 into 2, 4/3 pi r square into this r. What am I left with? 4/3 pi r cube, which is the volume of sphere. We have learnt about this in our theory class, and today we have actually practically derived it, isn't it? Now you are going to perform this activity and will, for yourself, you will derive this formula also, right? Thank you.